Hi everyone. This presentation is about the Step Counter mobile app. It is presented by Bhargavi Peruri, Chandrasekhar Velaru, Harilal, and Jayakumar Vinagamurthy. First, Chandrasekhar is going to start with the project overview.
Project Overview. Purpose, Scope, and Objectives. Step Counter is an activity tracking system which is developed as a mobile app to track the day to day physical activity of a user. Step Counter app counts the steps that are performed during a physical activity and calculates the calories burnt during the activity. Users will have a visual interface to check the steps made, the calories burnt during the physical activity, and a graphical representation of the activities using the Android graphs. Any Android mobile user can use the app. The personal data is stored in a secure RDBMS database and it will never be stored on the Android app. The salient features of the Android app includes a login and self-registration. So any user can sign up and authenticate the step counter app. Step counts and the miles walked. So the app counts the steps whenever it recognizes an activity on the mobile app. The calories burned. Based upon the steps, so custom algorithm has been implemented to calculate the calories that were burned during the physical activity. Graphical reports. Based upon the calories burned and steps count, so graphical reports have been generated and the user can view at daily, weekly, monthly, and on lifetime basis. The target audience for this report, for this Android app, are the fitness professionals, young adults, elders, mid-aged employees, and the people with the disabilities. Project architecture. A simple MVC architecture has been implemented in the project development. So the Android app is actually used as a view portion of the MVC. REST APIs have been implemented and they act as the controllers to create a proxy interaction between the Android app and the database. A database model has been implemented to store the data in a secured MySQL database. So what are the technologies we have used for the overall implementation of the Android app? We have used the Android development kit to develop the Android application. A Spring Boot application has been developed in order to expose the REST APIs from the MySQL database. The data has been stored in MySQL database. The whole architecture or the technology, the Spring Boot application, the MySQL databases, they have been deployed on the Google Cloud Platform. And majorly, we have implemented the security in order to authenticate the user such that only the user can access his own data. In the project implementation, we have a list of the project deliverables. Software project proposal, software project files, design and architecture documents, user training manuals, system test cases and results documents, and the project presentation, which will be a PowerPoint presentation with a voiceover and hosted on YouTube streaming platform. A few assumptions have been made in the development of the step counter Android application. A user should have an Android mobile device which will have a proximity sensor, accelerometer, and a gyroscope in order to track the footsteps and the motion of the body of the user. The application is developed based upon the US English language. Internet connection is mandatory in order to in order to make REST API calls from the Android mobile device. On the Android device, no data will be ever stored. This is to safeguard the user's privacy as well as to keep focus on the implementation of the user's privacy. The future scope of the project includes a BMI index algorithm, a custom activity or calorie input by the user, and a user can create his or her personal activity plan and a diet plan.
This is Bhargavi Peruri, and I'm responsible for the server-side infrastructure for our step counter project. We used cloud for our server-side infrastructure mainly because it has many advantages. It supports pay-as-you-go model, so there are no huge upfront costs with this model. And it's also billed by second, so we just pay for what we really use. And another important advantage of this cloud infrastructure is it's elastic in nature. So we are not limited by any server capacity that we bought initially. So we can add more server capacity to scale up, and this can also reduce our server footprint and it will save costs. And we have on-demand provisioning, which is typically less than 5 minutes, and it is highly available and there is very less downtime, and we can also back up the data, and it also has encryption as a security, and there is a disaster recovery, and it's also scalable both vertically and horizontally. We used Google Platform as a virtual cloud server. It provides infrastructure as a service, and it also provisions virtual servers on demand. And Google takes care of all the security and OS patches, and it's available worldwide. And it has high performance and low latency. And Google Cloud Platform, it just costs around $4 per month. And the hardware it uses is F1 micro instance, and it has one virtual CPU and 600 MB of memory and 10 GB standard persistent disk. So the software we used is Debian Server OS, and the OpenJDK version that we used is 1.8.0. We used MySQL database, and it's a relational database management system. We mainly used three tables for our application: the tracker table, personal data table, and account table. So the tracker table mainly has information about when the activity has started and when the activity has ended, and how many steps were taken during that activity, and the number of calories burned. And the personal data table has information about the user's personal data like height, weight, age, name. And the account table has the user credential information. This is the cloud infrastructure we currently support. The REST API runs on Google Compute instance, and the MySQL DB runs on another Google Compute instance. Running on Google Cloud infrastructure allows us to scale up the RESTful API web server to meet the increased demand in the future. Also, the MySQL DB can be scaled up both vertically and horizontally to support more traffic. The storage can also be scaled up even up to a petabyte level. Currently, we support Android device for our step counter project. Since RESTful API, MySQL database are running on Google Cloud Platform, we can easily enhance our project to support iOS devices or Surface tablets that run on Windows.
Hi, this is Jaykumar Vinayakamurthy. I'm going to walk through the list of screens in the Android app. In the Android app, it has splash screen, login screen, registration screen, and daily step count screen. This is a splash screen. This is the very first screen which displays once you open the app, and it shows for 2 seconds. Programmatically, we can change the number of seconds to be displayed. This is the login screen, and it requires username and password. So if the user is registered already, um, they can enter the username and password. Otherwise, they need to click on the register screen, and they need to register over there. So when the user clicks login, behind the scenes it's going to validate the username and password, and based on that, it's going to either allow the user to log into the app, or it's going to throw an error if it's an invalid user. This is the registration screen, and we are collecting a full name, date of birth, height information, weight, username, password, and we're confirming again the password is right. And once the user enter all these details, the user will enter the register, so that the user get registered into the app. So once user click the register, what it does is behind the scenes, there's a JSON request which sends the data to the REST API in the Google Cloud, and it is stored in the cloud database. This is the very main screen of the app. It is called daily step count screen. It displays the calorie, miles, step taken by the user for the day, and it displays the current date, and it also displays the option to select different reports. We have the calorie information that is derived from various inputs like the steps, height, weight, and other information. And the step count, we get the information from the phone sensor. So definitely we need a phone to have a built-in sensor to get the step count.
Any data without visual representation is not useful for the end user, so we have decided to create visual representation of daily, weekly, monthly, and lifetime activity. Let's look at the daily activity visual representation. In the daily activity report, x-axis represents the start time of the activity and the y-axis represents the step count during a time interval. Total calories burnt on a day is on the right top corner. Let's move on to the weekly report. This is the weekly activity of visual representation. In the weekly activity report, x-axis represents the day of the week and the y-axis represents the total step count of the day. Total calories burnt during the week is on the right top corner. In the monthly activity report, x-axis represents the day of the month and the y-axis represents the total step count of the day. Total calories burnt during the month is on the top right corner. In the lifetime activity report, a statistical representation of the data is presented to the user. The start date is when the user started using the app actively. The total step count and the total calories burnt is also presented in this report.
Thank you for watching the presentation. If you have any questions or clarification, please do post in the D2L MGA website. Thank you.